Hi, Amy.
Hi.
I couldn't resist. How's your juggling, by the way?
Mine, unfortunately, is not going so good.
We'll let you have a try later. I want to show you something first about equilibrium systems using the hydrogen iodine equilibrium system as an example. And, we don't need these. We have enough right here. Okay, now let's imagine that the surface of this table represents a given space. Call it 1 liter.
Okay.
What would be the concentration of the hydrogen and iodine that we have here?
Well, it would be 10 moles per liter for each of them.
Exactly. Now, the rate of the Ford reaction here is, well, you tell me. What do you think the rate might be?
I'd say it's pretty high because, I mean, if you look, we have a whole lot of them, a lot of the reactants.
There's many molecules in this confined space.
Exactly.
What do you think the rate of the reverse reaction would be, whereby we take products and recreate reactions?
I'd have to say that it would be non-existent because we don't have any products yet.
Okay, so as we create the first Ford reaction and start creating products, the rate of the reverse reaction is also going to increase. So what we'll do is we'll walk it through a few steps, and we'll imagine we could stop time and see where we would be as we progress towards an equilibrium.
Okay,
are you with me?
Sure, I'm with you.
All right, so we've got our first collision, and we create a pair of hydrogen iodide molecules. Okay, and we've got another collision, and a little bit more, and at the same time, you're going to start recreating.
I was just going to say, so now that we've got more, they'd start coming back to you.
Right, okay. Okay, good. And go a little bit more. Hey, oh, there's some more coming back at me. And some more. Okay, and, whoa, there's another one. And, whoa, okay, let's stop it right there. Whoa,
okay.
All right, perfect. Now, we're not at equilibrium yet. What's our concentration of reactants and products now?
Okay, well, I'd have to say that we have a concentration of 6 moles per liter on the reactant side for each, and a concentration of 8 moles per liter of products.
Okay, good. But we're not at equilibrium. So both the forward reaction and the reverse reaction continue.
Okay.
But there's an equalizing of the rates here. I'm starting to slow down. I'm getting a little tired here.
I see. So I'd start to speed up then.
Right. All right. So recreate more. And, oh, you're coming back. Whoa, you're going faster. Okay. All right. Well, okay, let's stop it right there. Whoa. All right. Now, let's count up what we have.
Okay, well, we have 12 moles per liter of products, and we have 4 moles per liter of each of the reactants.
Great. Okay. Now, we are at the point where the rates are now equalized.
Right, so okay, that makes sense. That means that we're nearing equilibrium then, right?
Well, if the rates are equalized, we'll tell you what. Work with me on this. Same rate, back and forth, okay?
Okay,
ready?
Sure.
Let's go. Okay. Back and forth. There we go. And, whoops, stop it again. Count.
I see, it's the same, so we are at equilibrium.
Exactly. You see, the rate of the forward reaction is balanced by the rate of the reverse reaction, so the numbers don't change. One more time.
Okay.
Okay, balanced. Okay, and stop it again. There we have it.
Same thing.
Okay, 4 moles per liter of the hydrogen, 4 moles per liter of the iodine, and
12 moles per liter of the products.
Okay, now note the numbers. I did this to reach a very important point here. Numbers are not balanced. Altogether, counting hydrogen and iodine, I've got a total of 8 molecules of reactants left at this equilibrium. You have 12 molecules. And that's a very important point. Equilibrium is not necessarily reached when the numbers of reactant and product molecules are equal. It's the point at which the rate of forward reaction is balanced by the rate of the reverse reaction.
Okay, so I guess we did show that equilibrium is dynamic then, right?
Well, I think we did.
I mean, you and I were both reacting our molecules at the same time.
Right.
So, does this mean I can try that juggling thing again?
Go ahead.
Okay. See if I do better this time.
All right. Whoa, almost.
Or not?